Okay, 5-2 properties of exponents and radicals. So we have already done some back and forth between radicals, so we're going to continue with that concept. Now, these right here are rules you know, right? When you multiply exponents, you add them. When you divide, you subtract. When you take a power to a power, you multiply. None of these rules are new. Oops, cross that out. Are they? Any rule here you see is new?
No.
Nope. None are new. And I can go from this direction to this direction, but I also can go from that direction to that, right?
Same thing.
I can do back and forth. These are examples. I just want to put that out there. We spent all last week reviewing these so we knew them well. That's why I made you do hundreds on them. Okay, so we are going to do these. As long as the bases are the same, everything works. Okay, so I have 81 to the 5/6 and 81 to the negative 1/3. So how do I do that?
Well, 81 to the negative 1/3 needs to be a fraction.
Hey, so this is too difficult and I don't want to do it.
Jenna, stop. So we would have to take 81 to the 5/6 minus 1/3, correct? Okay, so we have fractions, and before we can do it, we have to have what? To do anything with addition, subtract, common denominator. So what's my common denominator? 6. So that makes this 2/6. Okay,
What can you subtract?
so 81 to the 3/6, which is half. 1/2. So what does 1/2 mean?
I don't know.
Square root.
Square root. So what is the square root of 81? 9. So we're using our exponents. And you did this on that very last IXL, but you didn't have fractional exponents, did you? Okay. So the next one we're just going to, how about we go across? Okay, so we have 3 divided by 32 to the 2/5, all to the 1/2.
This is what confuses me.
Okay, we'll step through it.
Don't look at the whole problem.
Yeah, you just look at pieces. And don't let the fractions intimidate you. You know what to do, so you just have to do it. So first of all, that 1/2 distributes to both, correct?
Yeah.
Okay, so when we have a power to a power, we multiply. The power on the 3 is a 1.
So it's 1/2.
So I have 3 to the 1/2 over. Now, 2/5 times 1/2 is 2/5 times 1/2
1/5.
was 1/5.
Huh.
So I have 32 to the 1/5. Because these 2's reduce,
Okay.
and so that gives me 1/5.
I thought you did 2 times 5.
Well, why would you multiply then have to
It'd be
reduce?
2/10, and that reduces to 1/5. So yes, you can also.
So if you reduce before we multiply, our numbers are going to be smaller and easier to work with. Okay, so now it's 32 to the what power? Or 1/5. So what does that mean to do?
So it'll be 2.
It'd be 2 because it's the 5th root of 32, correct?
Yeah.
Which is 2. That was Monday and Tuesday you worked on that stuff, didn't you? So I now have,
Square root.
using properties of exponents, I'm 3 to the 1/2 divided by 2. Could I write it as the square root of 3 over 2?
Yeah.
Yes. Okay. I'm fine with either one of those, but I am going to tell you, you can't have a radical in the denominator, can you?
What's a radical?
This symbol is a radical. You cannot have a radical in the denominator, so you can also not have a fractional exponent in the denominator. And I will teach you how to get rid of those. It's rationalizing the same. Okay? So now I have x, y to the 3rd over x to the 1/2. All to the 2/3. Okay, so up here we had 3 and 32, and they do not have any common factors, do they? 3 and 32?
Uh-uh.
No. So we didn't do any reducing. Do I have anything I could reduce the x's, right? So I have x to the first divided by x to the 1/2. So that gives me what? What do I do when I divide?
I don't know.
Keep the change flipped.
No,
No. Keep change flipped.
no. Divide exponents. What do I do when I divide exponents?
And this.
Well, when you multiply, you add. So when you divide, you subtract.
I'm gonna read it to you.
Yes?
Yeah. So it's
Okay. So one, and you always go to the bigger one. Which one's bigger, 1 or 1/2?
1.
1. So 1 minus 1/2 gives you 1/2. So I now have x to the 1/2.
How do you know if it goes on the top or bottom?
Which one is bigger?
X.
To the first. So you're going to go up.
Okay.
Okay, and y to the third, all to the 2/3. Now, could I have distributed the 2/3 first and then reduced?
Yeah, but I mean,
But it would have been bigger numbers and harder to do. So now what do?
Multiply.
I multiply those exponents, right? So 1/2 times 2/3 is what?
The 2 is reduced to 1/3.
No.
So it's 1/3. And then I have,
3 over, so it'll be 2.
no, oh yes, it would be 2. Sorry. So y to the second.
How?
Because the 3's would reduce. Because this is 3 times 2/3. Okay, I didn't know if you saw it. Okay, so now again, I can leave it, depending on how they say to leave your answers, you can leave it x to the 1/2 y squared, or I could say y squared the square root of x. Right? So depending on how they tell you to leave your answer. And I'm not sure how they leave their answer. They do put it back into a radical. Okay. So now we have the next one. I have 2a to the 1/3 times ab to the 1/2 all to the 2/3. Now, I have to do the ab to the 1/2 to the 2/3 first, don't I? Because my order of operations says exponents, grouping symbols, then multiplication, right? And this is multiplication, so we have to do that. Okay, so I have to distribute this in to both. So I'm going to have 2a to the 1/3 times a to the 2/3 and b to the
1/3.
1/3. Now I can do my multiplication, yes? And the only common bases can be done because they have to be like terms. So what would I do with my exponents on these two? It's multiplication, so I add them.
So it'd be 2.
So it'd be 1 because 1/3 and 2/3 would be 3/3.
I'm not talking about that. We're done with
Oh, this 2.
Yeah.
Oh, sorry. So 2a to the first and b to the
1/3.
1/3.
Is that it?
Well, then we're going to put it back in radical form. So it's 2a to the what root? Nope.
Cube.
Cube root. So we got to put a 3 of b. So they look really bad when you look at them, yes? But if I step through them, are they that bad? No. You just got to step through them and you do one thing at a time. You cannot do them all at one time. It doesn't work. Not working. Questions on any of those before we go? No? Okay, so rewrite the radicals using properties of exponents to reduce.
16x 5
So it's going to be 16 to the what power?
5
No, 16 isn't to the 5/3.
Is it 1/3?
1/3. Why is 16 to the 1/3?
Because there's no exponent.
There's no exponent. Well, there is. It's a 1, right? And x to the
5/3.
5/3. Okay. So 16, we need to break it down as small as we can. 16 is what?
2 cubed.
2, not cubed.
Squared.
No,
2.
2 to the 4th.
Oh, that's what
Okay.
I meant by cube.
So,
Why do you do that?
because it says simplify using the properties of exponents. So that means we have to put it into exponential form.
Okay.
So this is going to be 2 to the 4th times 1/3. So it'll be 2 to the 4/3. Because you multiply them.
Yeah.
Okay. And then x to the 5/3. So we're using this to see what we can bring out of the radical and what has to stay in. So I'm gonna do it in more steps than I would normally right now. Okay? So 3 goes into 4 how many times?
Once.
Once. So I have 2 to the 1st, because that's one time. And then what is my remainder?
1.
1. So then I have 2 to the 1st times 2 to the 1/3. Okay? And now we're going to do x to the 5/3. So we're going to have 3 goes into 5 how many times? Once. And 2 are my remainder. Okay, so now we need to put these back into a radical. So the things that come out are the whole numbers. Yes? I should say whole exponents. Do they have a whole number exponent?
Yeah.
Yes. So I have 2x. Now what has to go back into the cube root?
Okay.
2 to the 1st
First. So 2.
and x to the, no,
Second.
2nd. Because the 3, where'd the 3 go?
To the root.
The root. So the 3 was the root, and we left our numerators as our exponents in the radical. Okay, so let's do it again. So I have the cube root of x to the 4th y squared over 125x. So first of all, could I reduce before I do anything with that cube root? I can reduce an x, yes? So
Make it x cubed.
So the bottom one's reduced out, and the top one comes to an x cubed.
So then it's 125, 1/3.
So it's, well, let's do the numerator first. So it's going to be x to the
First.
3/3.
Wait, why?
But it is going to be first, but I'm going to do it step by step. What?
I'm confused what you just said.
Okay, so we have x to the 3rd right here, yes?
Mm-hmm.
And so that's my numerator. And the root is 3, so that's my denominator.
I just,
Did I skip too many steps?
yeah.
Okay, so then I will go back.
Well, it's fine.
So I've got x to the 3rd, y to the 2nd, all to the 1/3.
Wait,
No, that's messing it up.
x to the 3rd?
Because we have x to the 3rd right here,
Yeah, but then.
and y to the 2nd.
Doesn't
But why is there a 1/3?
Y is there a 1/3?
Does it come
But
to
no, I'm
x
not
to
doing it.
1?
Yes. I just went back a step. Where'd the 1/3 come from, City?
I know where it came from, but that's not how I'm doing it. I have, so we reduce the x's, so I have the little squared root thing with the 3x3.
The cube root.
Over 125.
Cube root.
Okay,
Yeah.
so this is what you should have.
But it's not what I have.
That's what you should.
That's what you should have, though.
Why did I get a 115?
Because that's a number.
1/3.
Because this cube root is on the whole thing.
I don't like how you're doing it.
It's been the same. since it was.
Okay, so now I distribute that 1/3 in, yes?
So then it becomes x more
It becomes x to the 1st, y to the
5 2/3
2/3.
over.
Now, you can break it down, or you can know the cube root of 125 is what?
5.
5. So if you know that, do you have to break it down more? No. If you know it, you don't have to write 5 cubed to the 1/3. You can just write
5
5.
times 1/3
So now I got to go back.
1 5.
Can any y's come out of the radical?
No.
Why? You're right, but why?
What?
Can any y's come out of the radical?
The radical. No.
Why?
What radical?
Because there's none on the bottom.
There's like nothing to multiply with to get that out. Like, I don't know how to explain it. You know how like.
Well, how many y's do I have?
1.
No. How many Y's do I have? How many Y's do I have?
2.
2. I need sets of what? 3. So can any Y's come out of the radical? No, because I only have 2 and I need at least how many? 3.
So there's.
So X is going to stay.
That's what I meant to say, Nancy.
I know, I'm trying to just get you to say it right. And then it's going to be cube root of Y
Squared.
squared all over
5.
5. So I'm just trying to get you to think in the way that we can communicate it to other people and make sense. Because math is universal, so we have to learn how to universally explain it. We can't use our own language because your own language is bad sometimes. Okay, so now what's this one, the next one? We have the fourth root of 81, a to the 8th, b to the 5th.
So we're just plug it all in.
Do you guys want to break down 81 real quick?
Why?
Yeah.
Sure.
No.
Because we need to, right?
3, 3, and 2.
81?
Yeah.
No, try that again.
I'm doing the thingy.
3.
Oh, okay, so you're going, 81 is 9 times 9, yes?
Yeah.
So it's 3 to the
4.
4th. Okay, why did we go to the
I
4th?
said that, but I don't know why I said it so weird.
Well,
Yeah, you did say it
I
weird.
could have told you that before because it was 4 on the outside.
Right, you were looking for 4, right?
Yeah.
So we're going to go looking for the smallest we can get. If we were looking for 2, we wouldn't keep going to 3, would
Would have
we?
been 9.
We would have stopped at 9. Okay, so it's going to be 3 to the 4th to the what power?
4.
1/4,
1/4.
okay? And then A,
A, 8 over 4. B, 5 over 4.
and you can write it 5 over 4. I'm just writing them like this, so some people
And
might be a
then
little struck.
You multiply.
And then you multiply,
You get 3.
so you get 3.
2.
So A squared. Do we have any leftovers on either of these?
No.
No, so nothing's staying in the radical, right?
No.
Okay, am I going to have leftovers though? Yeah.
3, 2, 3 squared.
What?
Right?
Okay, 4 goes into 5 how many
A
times?
squared.
Yes, A squared. So it's 3A squared.
I said 3 instead.
I know. Okay, so 4 goes into 5 how many times?
B, 5.
Once. So 1 comes out. And then we fourth root
1.
of,
Okay, now I'm confused.
B.
okay,
Don't put any because-
so this right here, okay, we have 4 goes into 5 one time. Yes? And we have how many left over? 1?
Why do you have 1?
Because
It's 5
Because
fours.
what's 5 minus 4?
1.
1.
Okay. Okay, then I do square
She's
root.
gonna kick your.
No, you don't do square root. You do the fourth root.
That's the same thing.
No, it is not.
I just put a 4 on it.
Okay,
Why is that
again,
though?
do I, Jenna,
Can you stop?
please put your phone, Jenna, don't pick up your phone.
Okay.
Okay, so, again, did I do them all one time? No, I stepped through them. Now, stepping through them will go faster, and you'll be able to skip a few more steps as you get doing them, right? But you still have to step through them. Okay, so rewrite the product quotient of a radical. So basically simplify. Just different words to say simplify. Correct?
Yeah.
Okay, so how do you want to do this?
Mm,
It's all to what power?
Don't. But
It's all to what power?
the fifth,
What?
the 5th power.
Say that again. Not to the 5th, to the. It's the 5th
1/5.
root, so it's the 1/5 power. So I've. Sorry, jumped on me. Okay, so I have 16 times 8 to the 1/5. Because it's all, they're both in the 5th root, yes? So I can put them together. So what is 16? We got to break it down small, don't we?
2.
2 to the what?
4th.
Okay, so I have 2 to the 4th times 2 to the what?
3rd.
3rd, all to the
1/5.
1/5. So now what?
That's 2, 4 over 5, 2, 3 over 5.
What? No. Make it easier. 2 to the what power? At 4th
4 fifths.
and 3rds. What power is that?
12. 7.
7.
2 to 7.
I have 2 to the 7th to the 1/5.
So 2, 7 over 5. Or do you do the one thing you
So you do the division. So it's 7 over 5, right? Okay, so 5 goes into 7 how many times?
With 2 remainder.
1 time. So 2 to the first, and then 2 to the 2/5.
Why don't you put the little thingy?
What little thingy?
We don't do the little thingy.
'Cause
This?
Last time it was no.
Oh.
Last time it was like 7/5, and you're like, okay,
Right.
5 goes into 7 one time.
Well, I did it without writing it.
But this.
Where'd you
No, we will in a second. I didn't want to skip that step because we were losing city on it, so I wanted to make sure we showed it this time.
Okay.
Wait, so
Yes,
7
City.
minus 5 is where you get the 2 from.
Yes, it's the remainder.
So it's 2 7/5.
So
You just
it's
you
this
wrote it.
7/5 is 1 and 2/5, correct? City 7/5 is 1 and 2/5.
Sure.
It is.
Yeah.
Yeah. So the 1 is the 1 here, and the 2/5 is the remainder. Okay, so now it's 2 the 5th root
5th root,
of 2 squared, which is
4.
4.
They get a little confused.
They do, but don't rush them.
How much
Okay.
are we doing?
I don't know. As many as I have come up. We need to do them obviously together so you can do your
Why do you
homework.
do my homework?
I understand that, but you need to understand.
Hey, what is today?
252
Wednesday?
practical.
What, Carson?
I said the homework.
Oh, okay. So what do we want to do with this one, guys? Let's focus on what we're doing. Don't worry about the homework because the homework's not going to go anywhere if you don't understand it, right?
How about tomorrow?
Oh, let's go. What do we got?
Okay.
You have
Math
7
problem.
1/5.
Okay, 7 to the 1/5, please.
Why are you doing that already?
Okay, and then because we're moving on, we're done.
The five.
No, not that. I thought we-
16 to the 1/5. But can you break 16 down?
Okay, where do we want to go?
Break
16.
16 down.
Three.
Do
2 to the 3rd.
4.
2 to the 4th.
Okay.
Okay. Now, 2 to the 4th to the 1/5. Okay.
And then x 3 to the 5th. X to the 3 to the 5th.
3/5.
X to the 3/5.
You'll get it. You'll get it.
I'm close.
Okay. So I'm going to have 7 to the 1/5 over 2 to the 4/5
And then
and leave a blank. And we're going to have x to the
3/5.
3/5. Now, can anything simplify?
No.
No, nothing can simplify because nothing has a numerator greater than the denominator. But I told you cannot leave radicals in the denominator, so I can't leave fractional exponents in the denominator, can I?
No.
No. So we have to rationalize. So when we had 7 square root of 3, we would multiply by the square root of 3, square root of 3. And then we would get 7 square root of 3 over 3. Because this right here would be 3.
Yeah.
Okay.
Okay, we did that. We've done that before. So now we're going to do it with more than just the square root. So we need to think about what adds to get to the next whole number. So what would I add to 4/5 to get to 5/5?
1.
1.
1/5.
So I need to multiply by 2 to the 1/5. But if I do it in the denominator, I have to do it in the numerator. So 2 to the 1/5. Because 2 to the 1/5 over 2 to the 1/5 is just multiplying by 1.
Why
Doesn't
does that
change
have
it.
2?
What?
Why do you have 2 there?
Because you have to have the same base. Okay, so now I have x to the 3/5. So what do I need to do there?
X to the 2/5.
X to the 2/5. And when I do it to the denominator, I have to do it to the numerator.
The top.
Oh, you're kind of losing me.
Yeah, me as well.
Okay.
Just keep
You're just making whole numbers.
growing.
Okay, so now we're going to worry about the bottom. So what does this give me right here?
2.
It gives me
4.
just 2 to the first. It would give me 2 to the 5/5, which would be
1.
1, so I get 2.
So, okay, so you're only
2x.
multiplying the exponents, but the 2's don't do anything?
No, you don't change the bases, you're just doing the properties on the exponents.
Okay.
Okay, so now, what does this give me?
X.
X, because it give me x to the first, wouldn't it? Okay, so that's my denominator. No radicals, no fractional exponents, we're good. Okay, now the numerator. We do not have anything that is going to come out of the radical. How do I know that?
What do you mean?
Do you have anything that's going to come out of the radical? Look at your powers. This is a radical sign right there. Do you have any numerator that is greater than 5?
No.
No. So is anything going to come out of the fifth root?
No.
No. So I have the fifth root.
Of 7.
What's 7 times 2?
14.
So why do you
14,
multiply those?
because it's multiplication.
Okay.
Okay? Times
X to the squared.
x second, x to the second. You can say x squared or x to the second, but you can't say x to the second. That's weird.
I thought you just.
I thought you said
the
X
same
to the
thing.
squared. Oh my goodness.
You
Wait,
say-
no, the way you said it was weird. I don't know what it was. It's okay. It doesn't matter. Okay, so that is called rationalization. We have done it with square roots. Now we're just doing it with different roots. Okay? So let's do it again. Rewrite the product quotient of the radical. So,
2.
can we reduce anything in the square root first and not in the square root in the cube root?
No.
No. Okay, so if we could, we would. Yes? So now,
Multiply 2n by 1/3. That would just,
so we have
Just
2
put
and
2n over 9n parentheses.
to the 1/3.
All of it and put 1/3.
thank you.
Well, but we want to do it in pieces because with the bottom is where we can't have the 1/3. That's our problem, correct?
Yeah.
So the top we can keep it together. The bottom one we want to piece it out. Can we break down 9? That might help us.
3
Yeah.
3.
squared.
Okay, so I have 3 squared. That's a 2. My brain doesn't know what a 3 looks like. So it's 3 squared times 1/3. So can I put 3 to the 2/3? Can we make that leap right now?
Yep.
Okay, so we're going to have to put something with it, yes? Do you want to leave a space? Well, I'll show you how I would normally do it. And then m to the what? 1/3. So I just put it on the end. So what am I going to have to add to the 2/3 to get to 1?
1/3.
So I'm going to put 3 to the 1/3. Well, when I multiply the denominator, I have to multiply the numerator. And I'm going to have to add what to 1/3 to get to 1?
When's Pi Day?
2/3. It doesn't matter, focus.
Hey, shut up.
Well, it says Pi Day.
Okay, so does everyone understand what just happened in the denominator?
Yep.
Other than this is not a negative. I just looked up there and my brain wanted to make that a negative.
I think
Why did I multiply by 3 to the 1/3?
Because it's the 1/3 is on the 2/3.
Right, I already had 2 3s. I only needed one more to bring it out of the radical, correct? Why did I multiply by m to the 2/3? Because I already had how many m's? 1, and I needed how many more? 2. Okay, so I forgot to put it up here, didn't I?
Ow!
Stop.
Now, let's worry about the denominator first. Am I going to have any radicals in the denominator?
Whoa.
These two are going to get me what?
3.
3. Just 3 to the first, isn't it? And these two are going to give me what? M. So my denominator is 3m. There is no radicals. There is no fractional exponents. My numerator, is there going to be anything I can bring out?
Yeah, no.
No. Nothing is going to be able to come out, is it?
No.
So I'm going to have the cube root.
Cube root of 3.
Well, I have 3 and I have 2.
2.
So 6. What's 3 times 2?
Oh.
6.
I was gonna say 12.
Okay. M to the what?
Because my brain's not.
2/3.
Not 2/3.
Second.
Second.
Squared.
And N
to the.
first.
Yeah.
Okay. Why did the denominators go away? Because I put it back in the cube root. Remember, the denominator is the root. The numerator is the power.
Yep.
Okay, so let's do it again with multiplication. Oh, we got a problem. What root is this one?
4.
4. What root is this one?
1. 2.
2. There's nothing there, so it's a 2. Correct?
That's a square root.
So can I Just multiply those together.
No.
No, you cannot.
Would that be?
Okay, so we need to do some simplifying. So let's worry about the first one. How can we break down 27?
3 to the 4th.
3 to the
Third.
third. So I have 3 to the 3/4. Where'd the 4 come from?
The root.
The root. X to the 2/4. I'm going to put 2/4 first, and then yes, we will do that. And then I have 3 to the what? What's this one? 3 to what power? 1/2. And x to the 1/2. Okay. So, you want to do x's first or 3's first? 3's? Okay. So, if I'm multiplying these two, because that's what all this is, right? I have to add the exponents. So, I'd have 3 to the 3/4 plus 1/2. Can I add those like that? Nope. What do I have to do? Common denominators. So that makes,
5/4.
just a second, 1/2 into what? Common denominator 4, 2/4. So I have 3 to the 5/4. You were right, Jenna. I just wanted to step it. Okay. And then I have x. Well, what is 2/4 reduced to? 1/2. So I have 1/2 plus 1/2. I'll write it just so you can see it, which is just going to be what? 1. Okay, so x. Okay, now what? Because I'm not done.
Now you need to get the
Leftovers and all that. So
4 goes into 5 one time with a remainder of 1.
I'm going to have 3 to the first and 3 to the 1/4, and then x. Can I put x right behind the 3? Because it's going to come, it's already out, right? So 3x, the 4th root of 3. So I couldn't initially put these two together, could I?
No.
But could I find common denominators and do it?
Yeah.
Yes. So there's a lot of things that fractional exponents allow me to do that I haven't been able to do till now. Where are we at on time?
Time to go.
A minute till 2 minutes? No.
It's 24.
Okay, just a second. These are adding, subtracting radicals. Now, when you did square roots, you learned if the radicand, what's the radicand? The stuff in it wasn't exactly the same, you couldn't do it, right?
Yeah.
Well, now you have to have the radicand the same and the root.
Okay, so
Does
I
that make
need the
sense?
radicand in the root.
So you have to the radicand and the root. So your assignment today, I don't think this is included in it, isn't it? I can't see it.
5 to 12.
5 through 12. I don't think any of these are in it. If they are, we will do everything but those, and we will do them.
Together?
Actually, let me look if
My hair's
they are. Okay, 9. Everyone listen to me. 9, 10, and 12 have addition, subtraction, but 11 does not. So 11 you should be able to do.
Okay.
So you will do 5, 6, 7, 8, and 11. I expect 5 problems done, guys.
Okay.
Okay, if you have questions on them, you have questions on them, but I expect 5 problems should be able to be done.
Can I come into our IEP today?